Okay, problem 8.5. Bases PQ and SR have lengths of 5 and 9 respectively, and they are 8 units apart. What is the area of PQRS? So, let's draw the diagram. We have two bases. Make the legs. And since PQ is the smaller base, I'll write that up here. PQRS. That has a length of 5 and 9. Now it says the distance between PQ and SR is 8. So that means going from one line to the other has a length of 8. Well, that looks an awful lot like an altitude. And an altitude should remind us of the area of a triangle. Now, one way to think about trapezoids is kind of like what we did on the very first problem in this lesson, would be to split up our quadrilateral trapezoid into two triangles. Now, I want to note that this height, any height, is the length from the top to the bottom or the line drawn from one of the tops to the bottom. So if I extend PQ outward like this, we'll do it a little bit better. And then I were to draw that same altitude over here, that would also count as my height, the distance from one base to the other. So, the reason I am doing that is because if I clear off what I have here, now I can take the original trapezoid and split it into two triangles, PQR and PRS. And by doing that, if I find the area of each triangle, I can add them together to find the area of the entire trapezoid. So, let's find the area of PQR. Well, that's 1/2. I'm going to say my base is 5. Then my height must be 8, because the height would be the distance from that vertex R to the base, or the line drawn from the base, PQ, which we know is 8. So, half of 8 is 4, times 5 is 20. Now, if I find the area of PSR, my problem will be done. So we have 1/2. I'm going to say the base is 9. Well, what's the height? It's still just 8, because the height would be drawn from the vertex P to the base, and we know that distance is 8. So, multiply that by 8. Half of 8 is 4, times 9 is 36. That means now we can add up the areas of the two triangles to get the area of the trapezoid, PQRS, which is just 20 plus 36, which is 56. And this is a common link with all our problems. Split the problems up with trapezoids into triangle problems. And since we know how to work with triangles, it's relatively easy to work with trapezoids now. And an important thing to note is that the area of the trapezoid equals the height of the trapezoid times the length of the median. Now let's go back and see how that would work. So let's get rid of some of the extra stuff in our diagram. And just note, we don't even have to draw the diagonal anymore. So, what is the length of the median of this trapezoid? Well, the median is the average of the bases. So that would be the average of 5 and 9. So 5 plus 9 over 2. Well, 5 plus 9 is 14, divided by 2 is 7. And to find the area, we would do 7 times the height, 8. And what does that get us? 56. Now this is commonly expressed as the formula 1/2 base 1 plus base 2 times the height. But an even simpler way to realize what the formula for the area is just median times the height.